Hello everyone, welcome to Chemizon Complete Chemistry. In our today's video, we are going to solve the question 13 of the same JAM 2022 paper, the major product formed in the reaction of, so this is the reactant that is given and it reacts with NaOET. Okay, OET, if you see NaOET, it is a large molecule. Okay, it is a bulky molecule, large or bulky molecule. So this will act as a base and it will not act as a nucleophile. Since it acts as a base, this is going to be which reaction? It is going to be elimination reaction. It is going to be which elimination reaction? E2 elimination reaction. We will see in a minute. So first thing is this is again, you can see this is again a question checking your two concepts. One is stereochemistry, that is whether you know to draw the product or not from the IUPAC name given, plus the organic reaction mechanism. Okay, so let us draw the first. What we have to do is first step is we have to draw the reactant. Okay, so it is 2-chloro-3-phenyl butane. Okay, butane means how many carbon? Butane means it should be 4 carbon. Okay, so let us draw butane 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. Okay, so now we have to assign stereochemistry. Second position there is chloro. So, okay, you assume chloro at any one of the stereochemistry, either above the plane or below the plane. Suppose I add above the plane. I write chloro above the plane, then other group will be hydrogen. Now what you have to do, you find out RS of this molecule. If it is S, then it is very well and good because in the question it is asked 2S. Okay, if it does not come out to be S, you interchange. Okay, now if we will check whether it is R or S. Okay, first priority will be for chloro as its atomic number is maximum. Hydrogen will be 4. Here if we see there are 3 hydrogens. Here there are 2 hydrogen and 1 carbon. 2 hydrogen and 1 carbon. So carbon has higher atomic number. So this one will get second and this will be 3. So 1 to 2 to 3 you can see it is clockwise. Clockwise means it should be R. Okay, R, and the fourth priority is below the plane. So the correct answer for this is R. But do we want R? No, we don't want R, we want S. So what we will do, it is very simple. We will change. Now Cl we have written on the wedge. We will change and write the chlorine on the dash bond. Okay, chlorine and the dash bond. Now if you find out RS, it is going to be S. Okay, we can confirm. Okay, let us draw the, here there will be hydrogen. Now let us find out the RS again. This will be 1, this will be 4, this will be 2, and this will be 3. Now 1, 2, 2, 2, 3 is R, but fourth priority you can see is on the wedge. So we will change and bring it to S. Okay, I hope you remember the rules for finding out the RS nomenclature. If not, you can watch the video. Okay, so this is 2S. Okay, so this is correct. Now we have to write down for the third carbon. Okay, again what we can do for the third carbon, let's say it is phenyl. Okay, so I will write phenyl here. Okay, and on the dash bond I will write hydrogen. Here we have CH3. Okay, so now again we have to assign the priority. Now hydrogen will get fourth priority. pH if you see it is like this, phenyl. Okay, here all the three carbon is attached to all the three carbons. Here this carbon is attached to hydrogen, carbon and Cl. Here it is attached to 3 hydrogens. Okay, so which will get the first priority? Chlorine has the highest atomic number, so this will get 1. Then this will get 2 because here all are carbon, here all are hydrogen. So this will get 3. So 1, 2, 2, 2, 3, if you see it is anti-clockwise. Anti-clockwise means it is S. And fourth priority is on the dash, so the correct answer is S. But we want S? No, we want 3R. So here also we will do the same thing. We will interchange. Okay, we will interchange. Okay, what we can do is pH which was on the wedge, now it will become on the dash, pH and H. Okay, so this is the, here it is what? It is CH3 and here also it is CH3. Okay, so this is the final reactant structure of the reactant. Now what we have to do? We have to do the elimination reaction. For that, for an E2 elimination reaction, why here E2 elimination reaction will take place? Because if I remove this Cl, I will get this carbocation. Okay, and this carbocation, if you see, it is a secondary carbocation. It is attached to two other carbons. Okay, so whenever there is a secondary carbocation, which mechanism follows, it will be E2 mechanism. If it is a tertiary carbocation, then we would have done by E1 mechanism. Here it was Cl. Okay, so what is the condition for an E2 mechanism? That the hydrogen and the leaving group, here what is the leaving group? Leaving group is chlorine. Okay, hydrogen and leaving group must be anti-periplanar. Must be anti-periplanar. What is the meaning of this? We had already seen in our Klein-Freilog video. Anti means the bond angle between H and Cl should be 180 degree. Periplanar means both should be present in the same plane. Okay, so what we have to do? We have to bring Cl here and we have to bring this hydrogen here so that they come in one plane and the angle will also be 180 degrees. So how we can do that? Okay, Cl we want here. So we will bring Cl here. CH3 will come here and hydrogen will come here. Okay, let us do this change first. Okay, so Cl is here. Hydrogen is above the plane. Sorry, Cl. Then here we will get methyl and hydrogen will be below the plane. And then again here also we can do the change. We want hydrogen to be here in plane. Okay, hydrogen comes here, CH3 will go here and pH will come here. So what we will get? Hydrogen is in plane. Then on the wedge bond we have now pH which was on the dash, it comes on the wedge, and here on the dash we have CH3. Okay, so here you can see what is the angle between Cl and H is how much? It is 180 degree, and this plane bond means they are in plane, so this is anti-periplanar condition. So the condition is satisfied. Now what we can do? We can do the reaction. Now it is very simple. OET minus, it is a strong base. So it will abstract this proton. This electron will shift here. Cl will go away as a leaving group. So what we will get? We can draw the final product now. Carbon, double bond carbon. Okay. So here you can see at this carbon CH3 is below the plane and hydrogen is below the plane on this carbon. So CH3 and H will be cis. CH3H. Next is pH and methyl. pH and methyl are cis. So this is the final product. Now another important part of stereochemistry that we have to do is we have to find out the EZ nomenclature. Third step is EZ. How do you find out EZ? Assign the priority based on the atomic number. Here if you see, all are hydrogen. Okay, for pH we saw just now, all will be carbons. Okay, so which will get first priority? This will get first priority. This will be 2. Here hydrogen and carbon. So this will be 1 and this will be 2. Now we know both the higher priority groups, that is 1, if they are on the same side, then the notation is Z, and if they are on the opposite side, like this. Okay, if it was like this, that both the first priority groups are on the opposite side like this, then the stereochemistry would have been E. So here you can see this is the first priority, this is the first priority, both are on the same side. So this is Z. Okay, Z, and how do you write down the IUPAC name for this? this will be, how do you number? You number from here because here we have substituent and substituent should get the least number. So 1, 2, 3 and 4. Okay, so the correct answer will be, first we write E or Z. So here we have Z, Z 2-phenyl. Okay, 4 carbon means bute. So 2-butene. This is the correct answer. So Z, okay, so we can write either we can write Z 2-phenyl 2-butene, or another way of writing is Z 2-phenyl butene. Okay, both the methods are correct. So the correct answer is option B. Okay, this was another very important question where three concepts were checked: whether you know how to find out RS, whether you know how to find out EZ nomenclature, and whether you know E2 mechanism or not. I hope you have understood the solution. Thank you.